All right, hello, this is Mrs. Lopez, and we are still working on lesson 9 in our module 1 and operations in scientific notation. So, in my previous video, I explained you how to add numbers written in scientific notation. If you haven't seen it, please watch it, and I'm going to add the link to that video in the description for this. But also, I would like now for you to practice it and do the addition and subtraction in scientific notation. So take a moment, pause this video, and do this first table, change these numbers into scientific notation before we move into the exercise 7 and 8. So pause the video, change the numbers in standard form into numbers in scientific notation, and we will go from there. Okay, so here are the answers. Please check them before you move on. So for California, scientific notation of the debt is 4.07 times 10 to the 11th. New York, 3.37 times 10 to the 11th. Texas, 2.76 times 10 to the 11th. North Dakota, 4 times 10 to the 9th. Vermont, 4 times 10 to the 9th, and Wyoming is 2 times 10 to the 9th. In population, from top to bottom, we have 3.8 times 10 to the 7th, 1.9 times 10 to the 7th, 2.6 times 10 to the 7th, 6.9 times 10 to the 5th, 6.26 times 10 to the 5th, and 5.76 times 10 to the 5th. If all of your answers are correct, now you can move on to the next exercise 7 and exercise 8. Please pause the video, do the exercises, and I will check with you in a bit. All right, here we are checking the work for exercise 7 and exercise 8. For part A in exercise 7, they're asking us to find the sum of the debts of the 3 most populous states. So we are looking for the 3 numbers that are most popular, have the most population, and this is 3 states that have the most population, and that is Texas, New York, and California. So we are adding these 3 numbers. We are adding the debt of these 3 states together. So these are the numbers that we are adding: 4.07 times 10 to the 11th plus 3.37 times 10 to the 11th, and plus 2.76 times 10 to the 11th. First thing that we want to look at is the powers of 10, the magnitude of all these numbers. The magnitude is exactly the same because in all 3 cases we have 10 to the 11th. So that means that I can take 10 to the 11th and use distributive property to put it outside the parentheses. And I can combine 3 numbers inside the parentheses. After I combine these 3 numbers, I will get 10.2 times 10 to the 11th. But 10.2 is not written in scientific notation because this is more than 10. I need to make sure that my number is in between 1 and 10, right? So I'm going to change 10.2 into scientific notation by moving my decimal to 1 space over to the left, which is 1.02 times 10 to the first, right? Because it was 10 initially. And then I have times 10 to the 11th. And after that, I'm going to just combine the powers of 10, and that becomes 1.02 times 10 to the 12th. Okay, so that was part A. Part B is the same thing, but now we're just combining the sum of the debt of the 3 least populous states. So we're adding these 3 numbers together. 4 times 10 to the 9th plus 4 times 10 to the 9th plus 2 times 10 to the 9th. The magnitude is also the same. We have 10 to the 9th in all 3 cases. So we are going to use distributive property and put 10 to the 9th outside of the parenthesis. After we do that and combine the numbers inside, we are going to get 10 times 10 to the 9th. But again, 10 is the same as 10, but our number has to be smaller than that. So we are going to change 10 into scientific notation by writing it out as a product of 1 and 10 to the power of 10. 10 to the power of 1, sorry. So I have 10 to the power of 1 times 10 to the power of 9. And after combining the powers of 10, I will get 1 times 10 to the 10th. And that is the answer for part B. Part C. How much larger is the combined debt of three most populous states than that of the three least populous states? And obviously, we need to write our answer in scientific notation. Because they're asking us how much larger, they're asking us to compare them using subtraction. They want us to find the difference between the two. So we are going to subtract our first, the answer from part A and the answer from part B. So 1.02 times 10 to the 12th minus 1 times 10 to the 10th. Notice that the magnitude is different of these two numbers. That means that I have to change my magnitude to make it the same. Just like in fractions, when you need to find the common denominator, right? We need to make sure that the magnitude of my numbers is the same. So I'm going to change 10 to the 12th into 10 to the 2nd times 10 to the 10th. When I do that, I would be able to multiply my 1.02 by 10 to the 2nd to get rid of that 10 to the 2nd, so the only power I have is 10 to the 10th. So I'm multiplying 1.02 by moving my decimal twice to the right because we are using second power, right? And it becomes 102 times 10 to the 10th minus 1 times 10 to the 10th. Now I can use distributive property to separate my 10 to the 10th and put it outside the parentheses and do the subtraction of 102 and 1. I will get 101 times 10 to the 10th. 101 is not written in scientific notation. We need to change it by moving my decimal to the left twice. That means I'm going to multiply it by the power of 10 by the power of 2. So I will get 1.01 times 10 to the 2nd times 10 to the 10th. And then after that, I'm just going to combine the powers of 10, and it becomes 1.01 times 10 to the 12th. Exercise 8. What is the sum of the population of the three most populous states? So again, I'm going back to my table and I'm looking at the population graph right now, the population column. The three most populous states are these ones, so these are the numbers that I'm going to add together. 3.8 times 10 to the 7th plus 1.9 times 10 to the 7th plus 2.6 times 10 to the 7th. The magnitude is the same, so I'm going to take 10 to the 7th outside the parenthesis and combine inside. I will get 8.3 times 10 to the 7th. That is the answer for part A. For part B, we are doing the same thing, but with the least populous states. By looking at our table, we can find those numbers that we are going to add, and that is 6.9 times 10 to the 5th plus 6.29 times 10 to the 5th plus 5.76 times 10 to the 5th. The magnitude of these numbers is the same, so we are going to take 10 to the 5th outside the parentheses and combine inside. And I skipped that step. I just combined the numbers. 18.92 times 10 to the 5th is our answer here. However, it's not written in scientific notation. So we will change 18.92 into scientific notation first. It will be 1.892 times 10 to the 1st because originally it was 18. So I need to multiply by 10 to get to that number, right? And that is times 10 to the 5th. So I'm combining powers of 10 now, and I get 1.892 times 10 to the 6th. Okay, so my part C is a little bit different from the one that we did before. We are asked at approximately how many times greater is the total population of California, New York, and Texas compared to the total population of North Dakota, Vermont, and Wyoming. Since they're asking us how many times greater, that means I have to compare using division. And that's how I set up my problem. I'm dividing my first answer, 8.3 times 10 to the 7th, by my second answer, 1.892 times 10 to the 6th. This is the quotient rule for laws of exponents, the one that we studied earlier in this module. We divide the numbers that are coefficients, right? We are dividing these two numbers because this is a division problem, and we subtract powers of 10 according to the quotient rules for exponents. And we get approximately, this squiggly line means approximately, 4.39 times 10 to the first power. And since it's only times 10, I can just make it a standard form, which is 43.9. Okay. Exercise 9. You probably didn't do exercise 9 yet because I told you not to, right? But if you pause the video and do it and then compare the answers with me, then you can do that. Exercise 9. All planets revolve around the Sun in elliptical orbits. Uranus's furthest distance from the Sun is approximately 3.004 times 10 to the 9th kilometers, and its closest distance is approximately 2.749 times 10 to the 9th kilometers. Using this information, what is the average distance of Uranus from the Sun? So to find the average, we need to combine the distances and divide by the number of numbers that we have. And that's what I did here. I wrote these two numbers and as a sum and divided by 2. The magnitude of these numbers is the same, so I'm going to take 10.9 outside the parenthesis and combine within the parenthesis. So I will get 3.004 times plus 2.749 times 10 to the 9 divided by 2. My next answer is right here. It is 5.753 times 10 to the 9th, and that is divided by 2. And all I need to do now is to divide these two numbers to get my answer. 10 to the 9th power will stay the same. Nothing is affected here. So I will get 2.8765 times 10 to the 9th. The number is written in scientific notation because 2 is in between 1 and 10. And that is multiplied by the power of 10. Okay, so that is our work for our classwork exercises for lesson 9 in module 1, scientific notation and addition and subtraction and scientific notation.